Relations. So we start in section 2.5, Introduction to Relations, definition of a relation. This example, this definition here is a bit confusing. I don't like it. This is, we are following this book, this reference book, right? And I don't like it very much because it says many naturally occurring phenomena, two variables, and this is difficult. Relation is something very, very simple. Is when you have a number, and this number have a relationship. You can establish this relationship, or this relationship can be natural. Like in this example here is about the femur, the length of the one of the bones of your body, and your height. This is there is a relationship, and this is the example. It gives x is going to be the length of the bone, and y is going to be the height of the person. And they say, some scientists say there's a relation, there's a correlation, so you can link, you can find out the height of the person if you have the length of the bone. Well, this is a bit confusing, I gotta tell you. Relation is something much, much easier. It's when you can establish ordered pairs, when you connect, you link one number to another number. And you will see a few examples a bit later. So this is an example. This is not wrong, but I think is a bit confusing. Okay? That definition, this is something that's really important that you have to memorize. You have to remember. The set of first components is the ordered pair. If you have the ordered pair, and the ordered pair is going to be like this, x and y, right? The first one is x, and the first one, you're going to call this the domain of the relation. So the first one is going to be the domain. The second is y. The second one is y. So the second component in the ordered pair is called the range of the relation. Okay, Kishore, don't forget to open your assignment, and then you're good. Okay, the second component in the ordered pair is called the range of the relation. And that's the thing that you have to memorize. You have to remember, every time you talk about domain, it's going to be x, and every time you talk about range, it's going to be y. I think you're going to understand this later, why it's called domain, why it's called range. But by now, you try to memorize. You try to keep this in your mind. Domain is x, range is y. Now let's check a few examples here. I will split this screen into two parts because we have two different examples. And this first one, letter A. Write the relation as a set of ordered pairs, then find the domain and range. So let's write the relationship here as a set of ordered pairs. And the first one, let's get this. X equals -7 and y equals -9. This is one ordered pair. Another one, x equals 2, y equals -9. Another pair, x equals 3 and y equals -9. Domain. What is the domain here? Domain. Domain is going to be x, all the x's. So, domain here, -7, 2, and 3. And the range. Range is going to be all the y's. -9, -9, and -9. You don't need to repeat, just -9. Okay? So this example, we have the domain, 3 numbers, -7, 2, and 3, and the range, just one number, -9. Next example, the other example, we have the rectangular coordinate system here, the xy plane, Can you see? And we have 5 points. 1, 2, 3, 4, 5 points. The coordinate of point 1, x equals -2, y equals -3. Point 2 is going to be x equals -1 and y equals 0. Point 3, x equals 0 and y equals 1. Point 4, x equals 1, y equals 0. And point 5, x equals x equals 2 and y equals -3. That's it. There's the relationship as a set of ordered pairs. Now let's find the domain. Domain, all the x's. So all the x's. -2, -1, 0, 1, and 2. And the range, all the y's, -3, 0, 1, 0 again, don't need to repeat, and -3 again, don't need to repeat. That's it. This is the domain, and this is the range, and that's the range of this example, letter B. Any questions so far? Those are simple ones, simple examples that you have ordered pairs, you have points, right? You don't have a lot of points, just a few points, right? And that are going to be represented by a few ordered pairs. Now let's check another example. That's actually equations, are relations that are represented by more elaborate graphs. Let's check. Does not seem to be hard. Yeah, this doesn't seem to be hard. It's not hard because of just points. The next one is not hard, but it has some tricks. We need to learn some tricks on the next one. And I will show a few tricks here. See? Finding the domain of ranging of these relations. Use interval notation. For this, there's not just one point. See, not one point, not a few points, but a whole bunch of points. A whole bunch of points. There's all these points here between -8 and 8 are in the domain. So let me split here in two. We have two examples. The domain here, domain is going to be all the points between -8 and 8. And we will represent using interval notation. Remember interval notation? The brackets, because 8 and -8 and 8 are included on the domain here. And range is going to be on the y-axis. The y-axis range is going to be here from -6 to 6. This is the range. So from -6 to 6. Okay? It's not hard. We'll have a few tricks. Let me show all the tricks here on the letter B. On this example here, letter B. Now letter B, check it out. We have one side here, one side of the graph, one endpoint of the graph is an arrow. And other endpoint is a ball, like an empty ball. This means, this arrow means the graph goes all the way to infinity. All the way up and to the right, going to infinity. See? And the ball, this empty ball here means the graph stops here, stops at this point, And actually, this point is not even included because it's an empty ball. See? Oops. This point is not included, but the graph stops here. Let's represent this domain of this. Domain is going to be the x. Check the x-axis. The domain starts here, and we're gonna go check the graph goes all the way to infinity to the right, so the domain also goes all the way to infinity. So domain starts on 0 and goes all the way to infinity. And the range also goes all the way to infinity, here, go to infinity, but actually starts not on 0, it starts right here. The domain starts here with an empty ball. The range is on the y-axis. The range is on the y-axis, starts on -2, and since it's an empty ball, you're going to use the parentheses, and goes to infinity, and every time I have infinity, you use parentheses. See, and Jacob was saying that that's not, doesn't seem too hard. Now, it's not the case that it's hard, but have a few tricks, right? A few things that you have to understand, a few tricks that you have to be careful about. Questions so far? Do you think it's easy now, Jacob, or a bit harder? Not too hard, right? Let's try now the bell work. Let's try the bell work, and then we're gonna be ready to work. Thank you, yeah. We're gonna be ready to work on the quiz after the bell work, okay? So let me clean this up and go to the bell work. Now you type your answer. What do you think is the right answer for this bell work? When Gene started the trip in Kissimmee, he was here in Kissimmee, he was 240 miles from Miami. After half an hour, he saw the sign on the road, he decided to keep the same speed all the way. And the same speed is not the speed on the sign. No, it's not the speed. It's the speed he was using on the first half an hour. How long was the whole trip? And think about it. Quick. So we found 4 hours as the answer for this quiz, for this bell work. 240 minutes in 240 miles. Okay, great. Let's go to the quiz. One example here of first part question that you have to find the domain. Let's work on letter A. Let me zoom in and work on letter A. The domain is going to be on the y-axis, so we're going to work on the x. Domain is x, and that's why you need to memorize. Domain x, range y. Domain x, range y. Okay, so domain you're going to work on the x-axis, and the domain here is going to be all these points, all the points here between 0 and here 4. Domain equals starts in 0 and goes all the way to 4. Every point, every number between 0 and 4 is part of the domain. Let's check an example to find range. And let me show one example here. Maybe this, G, letter G. Letter G. And now we're talking about range. We're going to work on the y-axis, And see the arrows. The arrows means that the range goes all the way to infinity, negative infinity. because of these arrows here. But it doesn't go up to infinity. It stops at this point. That means the range is equal, and we start with the least one. The least one is negative infinity to 3. This is the range. Now try to work by yourselves. I'm going to give you a couple of minutes, and then you work on the other questions. If you need help, let me know. After a couple of minutes, you can work together. Or if you want to check your answers, also type the answers on the chat box, and I check it out.